Welcome everybody to today's webinar, Geospatial Data Visualization in Python. So these are the topics covered in this webinar series. The first part was Introduction into Geospatial Analysis with Python for data scientists. The second part was a deep dive into Python GeoPandas built-in dependencies. Today, we're going to talk about geospatial data visualization in Python. And this part is going to consist of two sessions. Today is the first session. The second session is going to be on February the 21st at the same time as today. In the fourth part, we're going to cover geospatial data wrangling in Python. Part 5 is on working with geospatial data at scale, specifically on Amazon AWS. And the sixth part is called Geospatial Data Analysis Meets Machine Learning. And this series is brought to you by T-Systems and powered by Knut. And you can see watch all the previous webinars on the T-Systems YouTube channel. A few logistics before we get started. You can use the box to ask questions throughout the session. I'm going to look into those questions after the presentation and the demo part. There's also a handout, which is exactly the presentation that you're going to see today, including the links. And with that, let's get started. All right, so a quick refresher from the previous session, working with data in Python. How data is being processed in Python. Now, let's assume that you're working with non-geospatial data. And this can be any file storing tabular data, such as CSV. Python refers to that data as a data series. A data series is essentially nothing else but just rows and columns of data. And this data series is represented in a data frame. And a data frame is a tabular data structure with labeled axes of rows and columns. Okay, so by comparison, if you are working with a geospatial data, there's one slight difference. You'll see both have a lot of common, depending on whether you're working with non-geospatial or with geospatial data. But there are some slight differences. Okay, so an exemplary geospatial file can be, for example, shapefile. And Python refers to that as to GeoData series. And a GeoData series is rows and columns of geospatial data, including latitude and longitude. And this data is being represented in a GeoDataFrame. A GeoDataFrame is essentially a data frame with coordinates stored as two columns or in a WKT format. That's a well-known text format. And the only way to store data in GeoPandas is to create a GeoDataFrame. Now, what's the buzz? You're going to see that there's not much difference between how Python handles non-geospatial and geospatial data. Now, here comes the tiny little distinction, which is if you're working with geospatial data, you need to create a separate column in the GeoDataFrame holding latitude and longitude from the GeoData series as an object. And this separate column is called geometry. That's the tiny little difference which you have to bear in mind. Now, another quick refresher, working with Python GeoPandas. GeoPandas is the main library in Python for working with geospatial data, analyzing and visualizing geospatial data. Now, let's take a look how the different libraries under the hood of GeoPandas, how they work together. So first of all, there's Fiona. Now, Fiona's job is to read files containing geospatial data. Second comes Shapley, and Shapley is built specifically for analysis and manipulation of planar geometric objects. It's not for visualization, that's Matplotlib's job. Now, Matplotlib is the foundational library for visualization. Now, how do you glue Shapley and Matplotlib together? Here comes Descartes. Descartes is a library which is specifically built for gluing together Matplotlib and Shapley. And it plots essentially Shapley objects onto Matplotlib. Last but not least, there's CartoPy. CartoPy is the Python library designed for geospatial data processing in order to produce maps and other geospatial data analyses. And it's built on NumPy. And NumPy is the fundamental library for scientific computing with Python programming language. It has support for large multidimensional arrays and matrices and a large collection of high-level mathematical functions to operate on these arrays. There is a whole bunch of other dependencies and libraries, but we're not going to talk about them since they are doing their work in the background. So you're never going to touch those libraries. Those are the only ones that you're explicitly going to work with when analyzing data and visualizing data in GeoPandas. All right, so if you're working with geospatial data in Python, the best way to do so is using Anaconda, which is a very popular data platform. Now, there's one thing that you need to know. Now, and that is, how do you configure Anaconda for the purpose of visualizing and analyzing geospatial data? It took us a lot of time to figure that out, a lot of frustrations, and we're gonna spare you those frustrations. And it's very simple. It's a 3-steps process. So first of all, once you've downloaded Anaconda, or if you're already using Anaconda, first of all, install the Conda Forge repo. And a second step, deinstall the default Anaconda repo. And then in a third step, you can install GeoPandas. And once you install GeoPandas, all the dependencies and all the other libraries are going to be automatically installed. Life is definitely better that way. Okay. So now let's switch to the notebook and let's look into the code. So I'm just gonna look if there are any questions, but I see there are none. So I'm assuming that you can hear me, you can see the screen. In case that you have any trouble viewing this webcast, just let me know. And if you have any questions, then please type them into the box and I'm gonna answer them at the end of this session. All right, so let's look into the notebook. I'm just gonna move around some of the elements. I'm gonna sip some water. All right. So in this third part, we're talking about geospatial data visualization in Python. And this is the first session. In this first session, we're gonna solely talk about Matplotlib and GeoDataFrames. It's those two things, nothing else than that. Anything else will be covered in the second session. All right, let's get started. So far, in the previous sessions, we have covered the introduction to the geospatial domain and also the basics of Python geospatial ecosystem. Now, we will dive deeply into the very basics of what makes geospatial analysis possible in Python. We will use a top-down approach and start with visualizations first, because a picture is worth 1,000 words. And if you are able to see the outcome, then you are in a much better position to understand the how. Let's start with Matplotlib basics. Matplotlib is the de facto library for visualization in Python. Many of the geospatial visualizations tools in Python are either built on Matplotlib or they use different parts of it to draw the maps and charts. Okay, so what's the purpose of Matplotlib? To help you in visualizing your data as easily as possible with the necessary control. Most of the plotting is done by Matplotlib, PyPlot module, and this is how we're going to use it. Okay. Let me just scroll down a little bit so that you can see the code that we're actually using. All right. For using the entire Matplotlib, you have to write import Matplotlib. And for using only the plotting module, the command is import matplotlib.pyplot as PLT. So you can change the last word as PLT to as KPMM or as T-Systems or as Mickey Mouse or whatever you like. It's just a naming convention that instead of typing the whole part. And Matplotlib, essentially this is the kind of the creators of Matplotlib. considered PLT as the standard convention. So import matplotlib as PLT. So do that, life is better that way. And we are working in what we call a Jupyter notebook. And it's in a browser, as you can see here. And this is not only the only way we can use Python. There are many other interfaces to Python language, such as, for example, IPython or Python shell or IDE like Spider, or operating systems provide also their own interfaces, okay? So hence, to keep the consistency across all kinds of environments, Matplotlib draws the image or chart or visualization in the background, but it does not show it to you because it does not know how the environment displays it. So we need to tell it how to display. And since we are in a Jupyter notebook, we will tell it how to show the visualization with this code here. Okay, so let me scroll down a little bit so that you can see it. Matplotlib inline. The percentage sign is used to perform the so-called magic command. And this magic command tells Matplotlib that we are going to display the charts in the browser. If you don't apply the magic command, you will not see anything, not in a Jupyter notebook. All right. So at the beginning of every file with source code, you're going to put import matplotlib.pyplot as PLT, and then use the magic command %sign matplotlib inline. Okay, before we get started, let's talk about the Cartesian coordinate system. So I'm going to zoom out a little bit so that you can see on a sec. One more second, 2 more seconds. Okay, let me go even that small. Okay, so I'm gonna scroll down a little bit. All right, so this probably looks very familiar with you. Just to make sure that we're on the same page. In Python, you always use x-axis as the horizontal axis and y as the vertical ones, and also in that order. So whenever you read code in Python, GeoPandas, the number, for example, 2,3 represents the x coordinate 3 and the y coordinate, the x coordinate 2 and the y coordinate 3, right? And as an example, if you have the coordinates -3, 1, then this refers to -3 on the x-axis and 1 on the y-axis. Simple as that. Okay, so let me go back to that little bit enlarged view. Oh no, before we do that, let me show you one more thing in its whole beauty. All right, so let me go down a little bit more. Okay. So this image here shows, it's kind of a 10,000 feet view, how you're working with data in Python GeoPandas. So you're essentially working with layers of data, and each layer, if you will, has its own conventions for data representation. And each layer also uses kind of different mechanism to communicate with the layer above and below. So if you're, for example, coming from a BI background and you've been using Tableau or Power BI in the past, you're very likely used to just grabbing the data and dumping it into a visualization, and then the tool does the rest for you. Now, by comparison, working with geospatial data in Python is way more complex. But on the other hand, it gives you a great level of control and a great level of granularity in the ways you're visualizing your data and analyzing your data. Okay, so now let me just enlarge the view a little bit because we're going to talk about code now. So I'm hoping this is good enough. 110% should be good. All right, so let me go further down. Okay. So essentially, Matplotlib draws different visualizations in 2 layers. And those layers are figure and axes. First, you need to draw a figure, and then you create an axis. An axis is different from coordinate axis. Axis is in PyPlot module. An axis is the region of the visualization with the data space, whereas axis, with an I, is a mathematical term we use to draw graphs. And figure is kind of the whole visualization. And before we get into figure creation and visualization, we need to know 3 other concepts in Python. So if you're already familiar with Python, you know of these concepts, you're using them on a daily basis. If you are new to Python, then this is going to be of value for you. So there's essentially variable, list, and function. So let me just talk about those very briefly. So a variable is a storage location in memory, and it holds something we call value. So in the code above here, x is the variable and 5 is the value. And to find or use the value of x, we just have to call it like this, right? You just type x in the cell and you get the value that is stored in this variable. So you cannot use a variable if you have not defined it. It is called a variable because its value varies, which means that you can carry it or change it in any point of time. And you can also create multiple variables at the same time, as you can see here. We're going to talk about that later on. Okay, a function is like a black box of tasks. Just like you don't need to know how the black box works in order to use it, same way you don't need to know how a function works. You just need to know how to make use of it, how to apply it. A function takes some input and performs some task and gives you the output. Just like a variable, you have to first define a function, and then to use it, you call it. The only difference is that when you call a function, it will have parentheses. For geospatial analysis, in this series, we will be concerned only with how to use built-in Python functions and how to use those functions. So generally, a list is a place that holds items. And we can write down different items like these. It can be like, a list can contain shopping items like soap or 1 kilogram of wheat or clutch wire for the motorcycle. And a list is also the name of a Python data structure. We explained what a data structure is in the second part, and you can review that if you haven't watched this. And that works in a very similar way. Just like a variable and a function, we have to define a list first, and then we can use it. And this is how you do it, right? So you give it a name, and then you can populate that list. In this case, with soap and wheat and clutch for the motorcycle. And then you can call it, and that's the way you do that. And the cool thing about a list is that it contains variables and numbers. So you can put in an integer, a variable, or a string. You can put all kinds of stuff into a list. Okay, so now let's talk about the anatomy of visualization in MapLip. I'm again going to zoom out a little bit just to make the image visible in a whole. So maybe a little bit smaller. So this whole image that you're seeing here is called a figure. So that's the correct naming convention. And on this figure, you see different type of plots. You actually see 2 different type of plots. You see 2 line plots. Here's a blue line plot, and you see a red line plot. That's the first type of plots. The second type of plots is the so-called scatter plot. So this confetti here, that's the scatter plot. And this distinction is very important because MapLip deals with the different types of plots in different ways. Okay, so there's a few more details, but I'm not going to touch upon those. They're kind of not really essential for the purpose of understanding how to work with MapLip. Okay, so let me enlarge the view again. 110. Okay. So now let's create a very simple plot. Oops. Okay, let me just go to the up. So what we do in order to create a plot, first of all, we are creating 2 lists which hold the X and the Y coordinates. Second, this function creates a figure and it attaches an axis to it. And then with this function, ax.plotxy, you plot the function. It essentially plots and draws the figure. And you have to be very careful here. So we're not using fig.plot. We're not using this function to draw the plot. It's because axis is the data space, and figure contains the axis, and axis contain the data. So you always plot the figure with axes. Okay, this is a very simple line plot, and this is what it looks like. And you can obviously customize this plot in many, many different ways. So let's just touch upon very basic ones. So first of all, you can rearrange the shape of the figure. So you just use this argument here, fig size. So you can change it to, for example, 10 and 4 inches. And this is what the result would then look like. You can also add further information, or you can also change the colors and the line style. And there are various ways to do so. So as an example, you can change the color to red, and you can change the line style to dashed, and voila, this is the result. And there is an even simpler way to do so. Let me just scroll down a little bit. It's just by using this command here, in brackets r// double slash. And you get essentially the same result. And then you can also populate your plot with various other information, such as, for example, the title and the X labels and Y labels, and it goes on and on and on. You have all different types of functions that you can use to customize your plot. But this is just for starters, just some very basic customizations. So that was the very simple X versus Y plot. And one of the most used visualizations in the geospatial domain is a scatter plot. So that's the confetti that you saw before. How do you create it using MapLip? In case of a scatter plot, we do not need to create figure and axis directly, as we did before in the line plot. They can be created indirectly by piplot. So it's just simple as that. plt.scatter, and then X and Y axis, and then you define the title, the X label, and the Y label. It's just simple as that, and then the plot is just being displayed. Okay? And now let's create a little bit more complex scatter plot. So we're going to change those lists. So we're going to populate them with just arbitrary numbers. Those are the two variables representing the X and the Y axes. And again, we're going to plot it. This time we're going to change the color to orange. That's the only difference in style. And so this is what you get as a result. Okay, so that's just a very brief introduction into Matplotlib, because you're going to be using it a lot when visualizing data in GeoPandas. Okay, now let's talk about GeoPandas in general and some issues that you might run into. Okay, so GeoPandas, like I said before, it's the library for general purpose geospatial data analysis and visualization in Python. It's built of many parts taken from several other libraries. Not all of the libraries are used directly. Most of them work in the background, and we don't even need to know that they are there, like PikeDal, for example. And some parts are used directly for analysis and visualizations, such as, for example, Matplotlib. Programmatically speaking, opening a data set and then doing some work and then saving it is known as reading and writing files. Four most used formats in geospatial data collection are CSV, JSON, shapefiles, and GeoJSON. And GeoPandas uses Fiona for reading and writing files. Fiona was created with one specific reason: to read and write geospatial files. It works in the background, but we can see all the formats supported by Fiona, and hence GeoPandas with this. So if you import Fiona, you can use this function to see which data formats are being read by Fiona. So there are some, such as for example, ArcGen or BNA or DXF or CSV, which most of you are probably familiar with. GeoJSON, and so on and so on and so on. And if you're wondering what these R and raw and RW, what that stands for, here's a brief introduction or explanation. R means that we can only read the file, but we can't write it. RW means we can read and write the file. And raw, oh, this is a typo. RAW should it be? We can not only read the file, we can also append and to the end to the existing file. Okay, so let's take a look at the anatomy of a GeoDataFrame. Right, the GeoDataFrame is the way data is being represented within GeoPandas. So two things are very important when it comes to understanding and working with any programming language. So it's the terminology and the standard conventions. So the sooner we get familiar with these, the better. It will help us avoid confusions and misunderstandings. And I will keep on introducing a few terms in every webinar, and you will be comfortable because it will be slow and lesser in quantity and hence easy digestible for you. It's a little bit confusing, I have to admit, because the different names sound similar to each other. But if you are confused, just go back, just review the presentation and review the recording once it's available. Okay, so as usual, we will start by importing GeoPandas. And GDP, GeoPandas, and GDF are three standard conventions in the Python community. So import pandas as GDP, and then read the file. So GDP.read file reads a file, a shape file, SHP file. This will create a new GeoDataFrame. And remember, what is a variable? So GDF in the code above is a variable which holds a GeoDataFrame. You can see what is inside by using GDF.head method. So by default, it's GDF.head and brackets, empty brackets. And if you put a number into it, you just tell Python how many rows you want to get displayed. So in this case, we only get 2 rows displayed because we wanted Python to do so. So GDF.head and 2 gives you just 2 rows. And as you can see here, the total number of rows and columns is 2 rows and 30 columns. So I said that already. The head is an operation to just look into the GeoDataFrame. Okay, and here's by default when you use GDF.head, then by default you're going to get the first 5 rows in the GeoDataFrame. There's a complementary operation to head, and it is called tail. And you guessed it right, it will show you the bottommost rows of data. If you go to GeoPandas website, and you will not find any documentation on head and tail operations. So GeoDataFrame is built on top of the pandas data frame. Hence, those operations actually come from the pandas library. Links are provided at the bottom of this notebook. So how to save a data set after you've finished working with it. So this is how you do it, GDF.toFile, and then you can give it any arbitrary name. In this case, we just called it 0. And that's how you save it as a GeoDataFrame. Now, how do we proceed in case that we're using a file format that is not a geodataspatial file format by default, such as, for example, a CSV file? Okay, so let's first of all read the CSV file. So we have a file that we're using for these demonstration purposes from Kaggle. The content of this file is essentially arbitrary. What we're going to talk specifically about is how do you deal with that type of data that is relevant for GeoPandas, and this is the location data. Okay, so reading a CSV file, this is not a problem at all. And if you look into the data frame, so again, you apply the head method, you're going to see the first 2 rows in this case. And now let's try to save this file. This is just a regular CSV file. We read this file and we want to save it. Now, if we're saving this file, we're going to get a very, very ugly and long error. And so you might be wondering, what's wrong? I have a CSV file it holds my geospatial latitude and longitude data. Why the hell does GeoPandas, why is it not able to process and save the file? Okay, now, I mentioned earlier in today's session the geometry column. So geometry is a separate column which holds the latitude and longitude data that you will find in a CSV file. It converts that longitude and latitude data into a separate column which holds that information, latitude and longitude, as an object. So in order to save your CSV file as a GeoDataFrame, you first have to create that geometry column, okay? So we need to convert the latitude and longitude data held in the CSV file columns into one geotag format and store this data in a separate column called geometry, and then we can write the file. So this is exactly what we're going to do now. So we will use Shapley in our case to create a geometry column out of the two CSV columns. Like earlier, as we did in MapLip, we will not import the whole of the Shapley library, but only the modules that we will need to create a geometry column. So from Shapley.geometry import point, apologies. To extract the latitude and the longitude from a CSV file, we will need pandas library. So we have to import pandas. And again, the convention is to import this as PD. So we are importing pandas. We're reading the CSV file. And as we see here, we have two rows and 29 columns. And we need to access the columns titled longitude and latitude. So as you can see here in head, I'm just going to show it to you. We see the location data, the latitude and longitude here, okay? Okay, now we need to convert that data into a separate object. So this is how we're doing this. Just flip this here. Okay, and so converting the longitude and latitude data into a geometry object, this is what we need to do. Step 1, combine latitude and longitude together as one item. So we need to create a tuple data structure from Python. Step 2, make a list, which is the data structure from Python of those tuples. And then step 3, convert the list to Shapley geometry. And step 4, add what we got above as a new column to the geometry frame. Okay, so step 1, combine latitude and longitude together as one item. This is how you do this. And you can pick any name you want. In this case, we just, for this to happen, we picked the name coordinates. And so this is how you do it. List, and then in brackets zip, and then df.longitude and df.latitude. So that's kind of the step 1 and 2. Combine latitude and longitude and make a list. And step 3, convert the list to a Shapley geometry. And this is how you do it. You apply point, .apply point. We can rename geometry column to anything. So in this case, like I said, we're calling it coordinates. For latitude and longitude are known as coordinates in geospatial domain. To add a new column, we can use GeoDataFrame operation. So this is the step number 4. And so what we do is gdp.GeoDataFrame and then df, geometry equals coordinates. And now when we check it, so let's apply the head method. We're going to see here, when you go, we have 30 columns now. And if we just look into that column, here we go. That's the coordinates. That's the separate column. That's the whole magic of converting your CSV file, which holds the latitude and longitude, into a separate column that can be read and understood by GeoPandas. So it's the devil's in the detail, and so you need to know those details. Once you understand them, you're going to feel comfortable working with geospatial data and analyzing it in pandas, in Python GeoPandas. So now we can save the file, and success. We are actually able to save the file correctly. Okay, So far, we have covered the necessary MapLip basics for geospatial analysis and also how to create GeoDataFrame from both geospatial and non-geospatial data formats, and also how to create geometry column if it does not exist. In the next webinar, we will talk about geospatial visualization using Cartopy and GeoPlots. Okay, so now let me take a look into the box if there are any questions. I see there are no questions. Just in case that you have any, feel free to ask them now, so just use the box. And if you joined us later during today's session, the recording is going to be available within the next few working days. You're just going to get an email notification. And in case you want to review the presentation, it's available in this box. You just go to handouts and then you can download the file. Okay, I see there are no further questions coming in. So with that being said, thank you so much for joining us today and hope to see you next week. Bye-bye.